Hello everyone, this is Sangeeta and my team are going to present a case study on autonomous rover using Multi Sensor Fusion. So first introduce yourself and start the case study.
Hi, I'm Rachana.
Hi, I'm Subiraj.
Hi, I'm Deepika. The objective of the project is a low-cost real-time multi-sensor fusion system that enables robust localization and data recording using Kalman filtering and complementary filtering. Kalman filtering is two state of a dynamic system, and complementary filtering means already collect the three data to compute the systems by fusing IMU, GPS and ultrasonic sensor data within a single loop on a hardware system. It reduces the sensor drift. Next, the abstract of the point is we implement the sensor system to perform a low-cost real-time that integrates the IMU, GPS receiver and ultrasonic sensor. So this is our prototype of the project. So here we have used Raspberry Pi Model 3, and it is the central part of the system which manages each and every process like data recording, Kalman filtering, complementary filtering and all the process. And apart from that we have used ultrasonic sensor which is used to find the obstacle, and it will navigate from it will find the obstacle and navigate through another direction. And apart from that we have used lithium ion battery which is a 16 volt battery, but we have used voltage regulator which is called as bug regulator. As it is a 16 volt battery, Raspberry Pi can only manage a 5 volt battery, so we have used the bug regulator so that it can regulate the voltage and send 5 voltage to Raspberry Pi. And apart from that we have used IMU. The IMU consists of gyroscope and
What is the IMU?
Inertial measurement unit. In that we have gyroscope, magnetometer, accelerometer. So gyroscope is used to find the x, y, z and direction, and magnetometer is used for find the path. And apart from that we have used accelerometer. It is used for speed, and we have used motor driver which is able to manage the speed of the rover.
Actually, we implemented the system using the Raspberry Pi. We programmed this using a Raspberry Pi OS, which programs using
Here
Python
I
programming.
have died. Why you choose Raspberry Pi?
Actually, Raspberry Pi can handle the multi-sensors, and it can have a unique processor called RISC-V.
How many sensors have you used here?
Actually, we used 3 sensors in a single loop for controlling the system. From the environmental data, the sensor that can get the input from the environment, and it can process using data recording and complementary filter algorithms. Using that algorithm, the rover can easily navigate the path. So we used the chassis with the steering type of tanker type mechanism for a continuous localization and for the movement. So it can easily move to a terrain map and also in a hardware paths. So it is a easy path. And also we used the motor driver for controlling the speed of the motor. Using these sensors data, it can easily navigate the path, and it can be easily localized using the GPS Neo section. And this rover is a low-cost solution for the upcoming rover-based challenges in mapping and for the monitoring purposes in planets. So we are using cameras and LiDAR for our upcoming future works to enhance this project and to improve our efficiency in the monitoring and for the localization areas.
What are the areas you can implement?
So we can implement in monitoring, like for the terrain mapping.
For terrain mapping, you have to include cameras.
Yes, ma'am.
And then what else you can include? Any other applications?
We can also include a ROS in this robotic operating system for easily controlling the robot. So it is a inbuilt open source platform. So we can implement it in a Raspberry Pi for controlling the robot in a precise manner.
So have you undergone any literature survey?
Yes, ma'am. We have undergone a lot of literature surveys for this. One of the major, as I have done that the multi-sensor fusion from the Chinese paper from Xi'an University. They have used the LiDAR and camera using for the GPS and for the terrain mapping. So by using them, we can easily optimize the work.
Okay. Hope this video will help you to understand how the multi-sensor terrain can be implemented easily. Thank you.